Hello, Spark fans. Welcome back to Advancing Spark, brought to you by Advancing Analytics, your friendly neighborhood data and AI consultancy. So, I've got a bit of a ramble, a bit of a rant to go on today. Now, not the same as the rants I've done previously, where there's a topic out on the internet that just annoys me and I feel like I need to get something off my chest. It's actually almost the opposite. It's almost like I'm going to come to the defense of a bit of hype that's out there because I keep seeing people dismiss it out of hand. And that is what AI means for the future of data engineering. Now, there's a ton of people who put out loads of fantastic content, helping people learn data engineering, pick up skills, learn the tools and concepts, all of that good stuff. But I keep seeing this consistent message of going, don't worry, data engineering is immune to AI. It's not, your job's not going to be replaced. There's lots of scoffing and dismissal going, yeah, but it can't talk to stakeholders, but it can't understand complex problems with the data. It can't tune this kind of problem. And that is perfectly true. AI cannot do everything a data engineer can do currently. But my problem is kind of this binary idea of that. It's either it's coming for your job and your job no longer exists, or it's not and you're perfectly safe to carry on as you were, and the answer lies somewhere in between. There's a lot of what we do as data engineers which is going away. I am sorry, but if you can automate it, and it's reliable and repeatable and easy, it's going to get automated and you're not going to do that anymore. And that's historically what has happened to the industry anyway. That's not a new thing. So I want to take a bit of time and talk through some of the things that we do as data engineers and which ones are ripe for the plucking to replace with AI. Some things have already been replaced and we don't even think about it, and some of which are the slightly harder bits. And this isn't to say you can go and get rid of all your data engineers, because actually to adopt all of this stuff kind of relies on you to have great data engineers already. So yeah, it's a bit of a mix. If you've got good people, you can do so much more because of AI. But the job changes. What those people do day to day changes because of it. So I've thrown together a super simple, quick deck. We'll have a look at some of these things. We'll dive and look at some examples. As always, if you're new around here, don't forget to like and subscribe and let me know down in the comments what you think about this. Have you already found some of your job has changed? Do you think some of your job fundamentally cannot be replaced? It's really interesting to know which bits those people think are. So let's dive over to the quickest of quick decks. Let's just refresh that and get that working. There we go. Cool. So there's this fundamental idea of saying, what do data engineers do? Well, we go into various different data sources, we pull it in and we do some modeling on it, and we slap it out to some users in a dashboard. And that's what people are saying, well, that can't be replaced. You know, this idea that your ChatGPT style thing will just go to your vast variety of source systems, run queries on the fly, and replicate data as well as a well-formed data model that's been properly designed with like good analytical kind of measures in there. The idea that that can just completely circumvent that whole process, madness. Currently, who knows? Maybe in 5-10 years it will be the case, and this stuff will be fast enough, and it'll be repeatable and trustworthy enough. But currently, it's not. I mean, the way AI works currently, it's a stochastic model. It's going to come back and generate results. You're going to have varieties in the approach it takes. And if you have variety in the definition of KPIs, it's not a good KPI. That is fundamentally against what we do. So that idea is not there yet. Maybe in the future, maybe with tons of work, you get something that comes close. But the effort to get there is far more than the effort it currently takes just to do some data engineering. So that's not what we're talking about. What we're talking about is different facets of what data engineering currently does and saying, well, actually, we don't do that bit anymore. We don't do that bit anymore. So a few of those example bits and pieces that we'll be doing. So data integration, the core, the bread and butter of what we do as an engineer is go off, find some data sources. So if I am working in an organization and they've got a ton of different applications, I go and speak to people who are requesting some data. Now, I speak to someone and they say, I've got this problem I'm trying to fix. And then I talk to a load of other people to go, right, okay, the stuff to help you fix that comes from this source system. That's really hard to automate via AI. If I have a fantastic registry of all my different data estate already plugged in somewhere with connection details and with data contracts about how I can integrate with that, sure, AI could do that. As it stands, actually going off and doing that automatically, that's kind of hard. That needs someone to go and design that currently. That's not that ripe for disruption currently. Building integrations, way, way more likely. And actually, to be fair, AI is not really going to help that much there because we've kind of already done it. You know, so the way we tend to do things, we build things that are dynamic and parameterizable. Maybe currently via whatever ETL tool you're using, you might build one generic connector for each type of data source. I go and build, this is my connector for SQL Server. Oh, you got a new SQL Server? Just plumb it into the existing one and parameterize it. It's fine. I just need some metadata to get that to run. AI can generate that for us, but it's not going to save us that much time. So yeah, integrations, it could do some stuff, but that's already fairly automatable. The next two, cleaning data. Cleaning data is a big one that is so ripe to do something magical with. So currently, the way a lot of things work, it depends on how you've built your data platform. But certainly the way AA work, we build metadata-driven platforms. So we'll build a super generic process. A bit of PySpark sat in Spark, waiting to receive some kind of config. So pick up data from here, apply these cleaning rules, write it down there. That's one script with a metadata lookup, because our engineers have already built it, right? Now, the idea of saying, well, actually, they're deciding which cleaning rules to apply. Looking at the data and going, well, I need to remove special characters from there. I need to make sure that's never null. I need to make sure that's between those ranges. I need to standardize that foreign currency. All of those things. That is a data engineering decision to decide how to actually clean and validate that data. Maybe driven by data stewards in the business, maybe by the engineers. Someone has to decide that stuff. Now, a long time ago, we're debating, would AI ever be able to do that for us? And it was kind of, well, you could build a rules engine, but it'd have to be a fairly complex, gnarly rules engine, or so super basic it's barely worth doing. It's getting a lot better. Now, the same with mapping schemas, saying, well, I've got my schema sitting, I sat in my silver layer of my medallion architecture. It's still in the original source schema, so I've got kind of third normal form, whatever application source it was. But I've got a generic analytical data model that I've grabbed. It's an industry standard one. It's one AA I've used before. How do I do that source target mapping? Again, that is a sat down, eyeball them, figure out where things come from. That can also be automated. So I've had a super quick go at actually going, can I just get ChatGPT? So not my own model, not a fine-tuned thing, no RAG, none of that. Can I just, in a prompt, try and get one of these things to kind of work? And the answer is yes. You actually can at a basic level. So let's dive over here. I'm in just straight ChatGPT. It is in the open world one. Don't send your data to third-party LLMs. I wouldn't do this with production information, but just as an example to show you what this looks like. So creating a persona that is a data engineer using a metadata-driven rules engine. Again, this only works if you've got a metadata-driven rules engine. So there's going to be JSON. That's what you need to do. You need to evaluate data set, determine the cleaning rules, produce the JSON output. That's what I want. I don't want to have to write JSON myself. I want this thing to look at a source schema and go, right, you want me to do that table? Oh, well, here's the contract for you. Here's all the metadata you need. And here's the transformations encoded into that same schema. That's a job we currently have to do, which is painful. I don't want to do that. So my engine that I've built has two current cleaning functions. So some PySpark functions built in there. Again, this is just a quick example I've made up. One that does some string cleaning, probably doing a regex replacing special characters, and one that's doing an SKU lookup. So it's actually taking the product SKU, looking it into a reference table, and then it's nulling it out if it's an invalid one. Probably wouldn't do that, but just as an example, right? So here are your existing registered data quality rules. Again, that is an engineer has gone off and built. Now, additional rules can just be written using Spark SQL. You don't have to use those PySpark ones. If you come up with a rule that doesn't fit, just generate some Spark SQL and make sure you replace. It's going to be an S string. Talk to the column function in there. That's fine. A little bit of, one-shot prompt engine, complex of refinement kind of stuff. Putting in, this is what my source contract looks like. Super basic. There's no data cleaning transformations currently. Here's an example of those transformations coded up in a way that I would do it. So if I was going to clean this existing table, well, I was going to call my cleaning addresses PySpark function. That's what that would look like. I'm going to do a manual bit of Spark SQL cleaning. That's what that would look like. So as part of my prompt, I've given it the context of the persona. I've given it the context of what I want it to do. I've told it what it can use currently and given it an example of what the schema is. And then everything brought together. This is what the final output looks like for that example. And then the job I want you to do, here is the table. Here's some basic information for you. Suggest the data quality rules. Build me a contract. Now, in reality, that's not what I would do on a full professional basis. I would have a much more detailed thing in there with a load more data quality rules it can use. a load more details about, naming conventions and how I wanted to do stuff, I'll provide more information than that because I can just get it to go and do a full scrape of the metadata from the source system to give it all of the information and the data types and the schema and everything. But even so, just as a quick hack to say, will this work? So it looks at that and it says, okay, these are the things I need to do. I need to clean the product name to remove any special characters. I saw something that was an SKU. I need to go and do a lookup. There's a big string description. We'll do some cleaning on that. Unit price, you've not mentioned anything to do with that, but I think we need to make sure that's not null because the unit price is going to be used for calculations. So it's gone through, it's suggested these cleaning rules. It's generated my contract for me based on it. So I've got this output of this JSON object in the schema I requested in valid JSON, saying, well, here's the stuff that you asked for. Here's the transforms that I've coded up in the same structure that you wanted. Here you go. Off you go. Go and use that. Now, again, that took me like 5 minutes to write up that example and go, right, is this going to work? Out it comes. So the idea of someone saying, oh, yeah, it'll never be able to clean data for you. Of course it will. Now, is that the be-all and end-all of data quality cleaning? No, absolutely not. It still needs someone to review those rules. It still needs someone to eyeball it and go, right, does that seem about right? Oh, it's missing that. It should have some more stuff in there. But currently that relies on someone to have that gut feel and go, here's the basics I'm going to add. So this is, again, just going to get me like that 70% there, 80% there. So I can just apply this en masse. I can load hundreds of tables in a better engineered version of this, generate these contracts, and then I'm just having to do the additional uplift. I'm just have to add value where it's required. Not that hard. On the other side, my second example, that kind of source to target mapping, I've done the same thing. So let's just grab this. I had the same kind of big blurb I was doing. Again, you're a data engineer. This is what you're doing. This time you've got data in your silver schema. We've got a destination that you're trying to map it to. Here are the various tables in your silver schema that you've got. So you've got the clients table with these different columns, sales items, transactions, transaction details, blah. A made up example of some tables I'm going to do. I actually got ChatGPT to generate these tables because, lazy. I've then got my analytical data model I'm trying to fit it to. Now, some of this is kind of the same, but transactions is going to have to map to fact sales. Clients is going to have to map to dim customer. Sales items map to dim product. I've not given any of that information. I've just said, this is what we're trying to get it into. This is what you've got. Can you please generate me the Spark SQL required to do that source target mapping? Now, we've been able to do similar things in the past. I could have built a whole rules engine saying, if you find something that's called customer or clients or called B2C or called people that we sell to, but I'd have to try and think of those different potential iterations. Whereas if I can use an LLM to do it, I can go, well, you know what a customer is. Find anything that's a semantic match to that in the data model and apply that via the mapping. And it's done that perfectly happily without me giving any additional instructions. And it's not perfect. There's a load of stuff in here that, again, it's kind of had a good crack at, but it's not done it the exact best way. So it's made me a fact table with all the relevant joined. It's worked out that customers is actually clients and about how it should join that from the source. It's figured all of that stuff out in terms of what it's trying to do there. It's assumed that I want to use row numbers to generate my keys. In actual fact, I probably want to use identity columns in my Delta table, but I didn't give that context. I could have improved that prompt to have that information in there. But it's had a good crack at it. And things like the margin, there's nothing in there that represented margin. I'd included quite deliberately in my source schema. You've got under the sales item, you've got the price and the unit cost. Under the actual transaction, you've got the total amount. You've got these different bits that it could use in the transaction details going, well, this is how many they ordered, this is the amount, this is the discount. And it's actually baked some of that into its response to actually know, okay, so going to be a line amount, then minus the unit cost and the quantity. It's trying to figure that stuff out in terms of what it's doing. Is it perfect? No. But if I can just go and see a client and hit a button and go, here's my generic data model, here's your data model that I've never seen before coming from your source schemas, and get 80% there the way with the mapping, that is a huge accelerator in terms of how I can spend my time. It's absolutely massive. And oh, my deck does not want to be appeared. There we go, have it go. So, just things I can speed up. The idea of being able to go, I can just click a button and it'll do source to target mapping for me. I can click a button and it'll do its best guess at what data quality I need. Huge. I can improve that by sending a sample of my data through to it. I can improve that by having a load of metadata and statistics in there. I can improve the source target mapping by including here's a load of common queries and sample information, and, you know, a write-up of this is what each field means, which I probably have. So loads of things I can do there. On the other side, it's not just about data loading, pipeline management. Well, code generation is already part of most of our tools now. We're already getting that Copilot style experience where I start typing something and it goes, oh, you're trying to finish this off, right? And we're already getting this thing where I'm trying to train people on Spark and I write something that's wrong deliberately to show people. I turn around to explain it and already it suggested what the fix should be behind me. It's getting harder and harder to write wrong code. Or like optimization. More and more we kick off a pipeline and it goes, actually, we just made it run faster behind the scenes. Don't you worry, we'll make it go fast for you. Especially with the move with things like Databricks going very more towards serverless, the more they're doing on their side, which again is very AI driven. So actually you don't need to do as much optimization as you used to. You still have to do some, but more and more that's going to get chipped away. We're going to do less and less and less of that as time goes on. Fault recovery, if things break, sure, currently we'll get an alert. We'll have to go and click a button, hit restart. More and more that's going to be actually, do you want the tool just to try and restart itself and to look at it and figure out whether it's just hit restart and bump it, figure out if there's a fault. Should it automatically fix that bug and continue? Most tools don't do that yet, but that's not far away, given how much the code generators are automatically going, oh, I'm just going to fix that for you. Oh, you made a mistake there, don't worry, here's the response. Do you want me to press a button and put that into your code? It's going to start happening that it'll fix problems for you. Not yet. It's not quite there. Anomaly detection, again, that's coming up more and more. The predicting spikes. The seeing a problem and going, what caused that? Oh, it was caused by this further down the line. That kind of stuff is starting to appear. It's the kind of thing we're going to be seeing heavily in the next year or two. Not 5 years away, not 10 years away. This stuff is starting to happen. On performance tuning, I mean, that's a much more obvious answer. Storage optimization, again, Databricks, managed tables, you're seeing it run optimizers for you. Liquid clustering, starting to suggest evolving the clustering that you're using. As usage changes, changing how it stores data in, because honestly, why should you spend your time doing that? That is getting so much more common. Again, query optimization, again, as you're writing a query, we saw really recently in Databricks, you can just write some SQL and then go just optimize, flash optimize in Databricks Assistant, and it will rewrite your query to be better. Happens in Snowflake, happens in loads of the tools people are using now. You can write a query and then just hit a button and it'll rewrite the query for you in a more optimal pattern. That is just getting baked into, again, the way we write code these days. And it's going to be caught up more and more in terms of when you run the code, it's going to look at that and then go, you should run it like this. And that used to be very rules engine based. I mean, that's not a new thing. Back in SQL Server 10 years ago, you'd write a query, you'd run it, and you get a little note going, you should probably put an index on there, it'll go faster. And that was just a rules engine based thing. Imagine how much more we can do with AI. And again, adaptive execution, that's more in terms of what the tools are doing inside. So that is essentially, as it sees there's spikes and troughs in terms of the work that I've requested, I've put a pipeline of work together, it's looked at how that pipeline normally runs, it can just decide to scale the cluster differently to actually get the most optimal use of CPU in there, that I don't have access to do that. I cannot physically sit there and go, I can tell clusters to auto-scale. I can say, well, if you get busy, start spinning up another box. I can't say, I predict you're going to be busy in 15 minutes. Why don't you start spinning up boxes there? And this is the exact nature of it too. But the providers, the vendors, Databricks behind the scenes, if I'm using serverless, can do that. They can start to pre-allocate stuff. They can pre-allocate things based on history. More and more using some kind of prediction to determine in advance the compute I'm going to use and actually pre-allocate it so my job goes faster. That stuff is already happening. I just don't see it. It's very black boxing. So, I mean, in the end of things, AI is absolutely fundamentally changing the job that data engineers do. It is. No matter whether you are sat there going, I am going to embrace all of this, yeah, you're going to be hit by it. If you're sat there going, no, it's not for me. Yeah, I'm using Spark, but I'm not going to use any AI myself. I'm sorry, it's already happening behind the scenes. The tools that you are using, everything you are picking up and using in the data ecosystem is starting to just drip feed this in behind the scenes. You might just see it as, oh, I mean, the tool I use has a new feature that makes my life easier. That's AI. It's things making things faster behind the scenes. And this is the example I used to try and do, going, AI isn't going to replace your job. Again, so many things I've mentioned just now of saying, well, I can get it to generate a contract. That contract has to be consumed into an engine, into a framework that I've built. I can get it to do a source target mapping. I need something to execute that and architect that. I need it to work. I need to have designed the data model that's mapping into. I need to have gone to the stakeholders and said, which things should I be building? There's a huge amount of stuff that you still need data engineers in the loop for to actually get all this stuff to work. But the amount that a single data engineer can get done, because all of the legwork is slowly being chipped away. There are things that we currently have to do that in 5 years we're just not even going to do. And honestly, that's just the nature of industry. When I started, long time ago, we had archaically slow data warehousing life cycles. Like every, 3-4 months, we'd get a data warehouse release done because it's a big bang waterfall effort. We had huge test cycles where we had to go and do regression tests on every single table in that warehouse in case something we had done had changed it. Because everything was so monolithic and intertwined in spaghetti code of SQL, you had to go and test everything every time. The idea of having something that's using data engineering, it's all code managed, I'm doing a deployment that is onboarding thousands of new tables, but it's all just metadata. So my actual my engine code hasn't changed. The metadata from my existing tables hasn't changed. I don't need to go and test that data. I know that works. I've got good, config abstraction. The idea of doing these big, massive regression test loads is completely alien to people these days. It's going to be the same. The amount of time that we spend actually manually coding up config, the time that we spend manually deciding on these two the same thing, the time that we spend manually performance tuning things that are going slow is going to get less and less and less. So in a few years' time, people will be going, you spent your time doing what? Why would you spend all your time looking at data spills and skew? That makes no sense. Makes sense now. As this happens, just the job is going to change. So your teams are going to be able to do more. You'll be able to deliver more value. Again, this super basic, quick example of going, what's the shift in time change? It's a change from actually spending all of your time doing tuning and config writing and having to go to the business and explaining what is actually happening and what the data means and all that stuff. As things like AI make it easier for people to ask questions and get explanations, a lot of the just explaining stuff should take care of itself. Should. It's a journey. It's not going to immediately. It's going to get better and better. The tuning stuff is going to get better. It's not going to be a light switch, but it's slowly a lot more and more of that job will just be carved away. Hopefully, more and more of what we do is going to be delivering value. So that is all I wanted to have a bit of a rant about today, just to go, yes, data engineering is fundamentally changing. It has already changed in the past year. The next 2025, 2026, 2027, we are fundamentally going to see so much of the work that we currently do just carved away and change. It's going to go away. Now, that's not going to affect absolutely everybody. It depends where you are. It depends what tools you're using. It depends if you're sat there and you do all of your data engineering using Excel on your local laptop. Yeah, it's not going to change that much because things haven't changed for you for quite some time. But if you're using any of the modern platforms that are innovating and doing a lot and investing heavily in this stuff, you're going to see the returns in that stuff just actually being drip fed into the ways of working. And it's kind of you can sit back and go, nah, that's not going to change my job. And it's not going to fundamentally replace you, but you are 100% going to be outperformed by the people going, right, which bits of my job can I just automate? Which bits do I just actually just pass off and cool? It's not going to do a perfect job, but if it does 80% and I just need to do the top up to make it perfect, and I just spend my time drip feeding value to fix the stuff that's just being automated for me, great. Imagine how much more work I can get done. Imagine how much more value I can deliver and how much happier everyone I work with is going to be if the turnaround times are tiny and just require me to do that little top up, make sure things are perfect. But it still needs a human in the loop to make sure things are perfect. That is what the data engineer can do. So yeah, that's my kind of almost counter rant. That a lot of the naysayers, a lot of the people on the internet going, don't worry, AI is rubbish. Look at this, it couldn't even write this properly. No, of course not. But it wrote most of it, and it will get you there. And that is the big thing. So you should be looking at your job currently and going, right, what's all the stuff that's manual and tedious? And I know how to do it, and I could teach a junior engineer how to do it, but actually I could also just put that into a big old prompt, put it into a repeatable framework, and then actually I just don't need to think about that again. There is so much potential. I've just listed a couple of examples, but it's huge. Cool. So that is my rant today about you should be looking at your job, figuring out where AI matches, figuring out where it makes sense. Do not send all of your private customer data out to a third-party thing such as OpenAI. Make sure that if you're using any of this AI automation, it is in a secure ecosystem where they are not retaining your data for training purposes and all of that good stuff. Have a bit of common sense with it. But be planning how you can use it because there's so much potential. Right, there you go. My little rant done. As always, don't forget to like and subscribe, and I'll catch you next time. Cheers.